astronomers have detected an alien signal coming from the closest star to our solar system.
They detected it in a very narrow band of frequencies, and that makes it, it cannot be through natural processes, a very narrow band.
The universe just sent us a message we can't ignore. A crafted signal from Proxima Centauri's habitable zone has left scientists in shock. This isn't random static or the usual noise of space. It's deliberate, intelligent, and undeniably artificial. Advanced technology captured this faint signal. Could this be the first real proof that we're not alone?
But beyond that, even if there are things out there, there's no way we can see them because the light just could not have gotten to us by now.
Let us follow this trail of cosmic breadcrumbs to its startling conclusion and brace for what might lie ahead. Dark extraterrestrial frequencies. Imagine receiving a postcard from a neighbor you didn't even know existed. That's what this could mean. Scientists initially brushed it off, thinking it was just a fluke. But after amplifying and scrutinizing the data using advanced technology, they uncovered something that made even the skeptics pause. This wasn't just a signal, it was a crafted message from the cosmos, and it was moving. The source seemed to be orbiting something deep in the Proxima Centauri system, hinting at a level of technology that we've never seen before. Then the message changed, as if it were responding to us. It's important to understand why this is such a big deal. Space is noisy. Stars, planets, and even black holes produce all kinds of signals, most of them chaotic and broad. But this signal was narrowband, a feature almost always linked to artificial sources. Natural phenomena just don't emit this kind of precision. Combine that with its movement away from the telescope, and it's like a red flag waving in the void. Someone made this. What really rattled scientists was the signal's origin. Proxima Centauri is close, cosmically speaking, and it hosts a planet, Proxima b, that sits in the habitable zone, where conditions might support liquid water and potentially life. If this signal is coming from there, it's like finding a breadcrumb leading straight to an alien civilization. And if it's real, everything we know about our place in the universe could be flipped upside down. But let's not get ahead of ourselves. First, there's the question of verification. The signal needs to be analyzed and reanalyzed to rule out any possibility of human-made interference or a misinterpretation of natural phenomena. This is where new technology steps in. Techniques like phased array multiplexing have allowed scientists to isolate and enhance signals like never before. By combining data from multiple radio dishes around the globe, they can pinpoint the source with incredible accuracy. Here's the fascinating part. This technology has only recently become advanced enough to detect signals this faint and complex. That means this isn't necessarily the first time aliens have tried to contact us. It's just the first time we've had the tools to hear them. The signal might have been sitting there for years, just waiting for us to catch up. Now comes the million-dollar question. What's the message? Is it a simple ping to say, "Hello, we're here"? Or is it something deeper, more complex, possibly a warning or an invitation? The truth is, nobody knows yet. Decoding it will take time, and even then there's no guarantee we'll understand what they're trying to say. But the fact that it's precise and deliberate suggests it's not just random noise. It's a message crafted with intent. Some might wonder why this is happening now. Why didn't we detect this signal decades ago? The simple answer is technology. A few years ago, our equipment wasn't sensitive enough to pick up something this faint. Now, with innovations like phased array systems, we're opening the door to a universe of possibilities. And this might just be the beginning. If this signal is real, there's a good chance others are out there waiting for us to listen. But what does this mean for humanity? The implications are enormous. For one, it would confirm that we're not alone in the universe. That's a paradigm shift on a scale that's hard to imagine. Religions, philosophies, and even politics would need to adapt to this new reality. On a more practical level, it could accelerate our efforts in space exploration. If there's intelligent life on Proxima b, it's no longer a question of whether we should try to visit. It's a question of when. Still, there are plenty of challenges ahead. Verifying the signal's authenticity is just the first step. Scientists need to determine if it's a one-time event or part of a series. If it's ongoing, it opens the door to a potential dialogue. But that raises another set of questions. How do we respond? What do we say? And how do we ensure our message is received and understood? There's also the issue of caution. Contacting an alien civilization isn't without risks. For all we know, they might not have friendly intentions. History on Earth is full of examples where one group's discovery of another led to disastrous consequences. It's something to think about as we move forward. For now, the focus remains on understanding the signal. Teams around the world are working tirelessly to decode it, analyze its properties, and determine its origin. Each discovery brings us closer to answering one of humanity's oldest questions. Are we alone? The discovery of this signal is more than just a scientific milestone. It's a reminder of the vastness and mystery of the universe. For centuries, humans have looked up at the stars and wondered if there's anyone else out there. Now, for the first time, we might be closer to an answer. And while there's still a long way to go, one thing is clear. The universe has secrets it's ready to share, and we're finally in a position to listen. But the details don't stop there. Researchers have revealed that the signal's frequency falls within a range commonly used in advanced communication technologies, further strengthening the argument that it's artificial. This isn't a random burst of cosmic noise. It's a structured and deliberate transmission. Such precision rules out natural sources like pulsars or magnetic stars, whose emissions tend to be chaotic and broad. Narrowband signals, on the other hand, are hallmarks of intelligent design. Another fascinating aspect is the signal's periodicity. It appears to follow a consistent pattern, as if it's repeating a coded message or transmitting a structured data stream. This kind of behavior is unheard of in natural phenomena and adds another layer of intrigue. Scientists are now working on algorithms to decode the possible message within the signal using techniques borrowed from fields like cryptography and linguistics. Meanwhile, telescopes around the world have been directed toward Proxima Centauri, searching for additional transmissions. The idea is to confirm the signal's authenticity and see if it's part of a larger communication effort. This requires a global network of observatories working in unison, a testament to how monumental this discovery could be. Let's not forget the potential origin, Proxima b. This exoplanet has been a subject of fascination for years because it lies within the habitable zone of its star, Proxima Centauri. The habitable zone is the sweet spot where conditions might allow liquid water to exist, a key ingredient for life as we know it. If the signal is indeed coming from Proxima b, it raises questions about what kind of civilization might exist there. Are they similar to us, or are they something entirely different? There's also the possibility that the signal isn't coming from Proxima b itself, but from a satellite or spacecraft orbiting the star. If that's the case, it would suggest an even higher level of technological advancement. Building and maintaining space infrastructure is no small feat, and it implies a civilization that's not only intelligent, but also highly resourceful. The signal's discovery opens the door to even bigger questions about the universe. The secret lives of ancient galaxies. The telescope's ability to peer deep into space, and by extension, time, has uncovered mysteries that boggle the mind. One of the biggest bombshells is a discovery that completely flips our understanding of the universe's size. Recent data shows objects that formed just 120 million years after the Big Bang. If that sounds ridiculously close to the start of it all, it's because it is. The implications? We might be totally off about the size and age of the universe. To grasp this, consider the idea of the observable universe. That's the bubble of space we can see, with light from its farthest edges taking billions of years to reach us. This bubble stretches about 46 billion light years in every direction, forming what's called the Hubble sphere. Anything beyond that is essentially invisible because the light hasn't had time to reach us yet. However, the Webb telescope's findings suggest the story doesn't end there. The universe isn't just expanding, it's accelerating. Imagine running on a treadmill that's speeding up faster than you can keep pace. That's what's happening to galaxies beyond the Hubble sphere. The space between us and these far-off objects is stretching so fast that their light can't reach us anymore. Eventually, the observable universe will stop growing, capped by what's called the cosmic horizon limit. Beyond that, it's a no-go zone for even the most powerful telescopes. But here's the kicker. Even within this boundary, the Webb telescope is finding galaxies that shouldn't exist according to our current models. For instance, one galaxy, nicknamed Maisie's Galaxy, popped up about 450 million years after the Big Bang. And then there's another contender, F200DBZ045, potentially forming a mere 168 million years post-Big Bang. These timelines are insanely tight for galaxies of such size and complexity to appear. To form these, nearly all the gas in those regions would have had to convert to stars with almost 100% efficiency. That's a level of perfection the universe isn't supposed to pull off. Let's not forget the massive black holes discovered colliding just 700 million years after the Big Bang. Black holes aren't supposed to grow this quickly, let alone start merging so soon. These discoveries point to a universe that's not only older than we thought, but maybe doesn't even have a clear beginning. This brings us to the idea of infinity. If the universe is infinite in size, could it also be infinite in age? What if the Big Bang wasn't the start of everything but just a phase in an endless cycle? It's a possibility that's hard to wrap our minds around, but it's becoming harder to dismiss. Then there's the light we're seeing from these ancient galaxies. When we look that far out, we're not seeing the present. We're seeing snapshots from billions of years ago. The galaxies near the edge of the Hubble sphere existed long before our solar system even formed. In fact, we're not just looking at distant places, we're looking back in time at the universe's baby pictures. But here's where it gets weird. If the universe is infinite, then the Big Bang couldn't have been a single starting point. Instead, it might have happened everywhere simultaneously. Think of it like this. Instead of the universe exploding out from a dot, it was more like every point in space suddenly bursting into existence at once. That's why we see the cosmic microwave background radiation, the first light, everywhere we look. It's the glow from matter's grand debut, lighting up the whole universe at the same time. And yet, even this grand idea is under fire. The Webb telescope's images are showing galaxies that don't fit our 13.8 billion-year-old model. If these findings hold up, we might need to rewrite the age of the universe entirely. It could be older, or, brace yourself, it might not even have a starting age at all. Adding to the confusion are estimates about the universe's actual size. Some theories suggest it could be at least 250 times larger than what we can observe. Others go full mind-blown, suggesting the universe could be 10 to the power of 10 to the power of 122 times bigger. That's a number so big it's basically meaningless. And yet the way matter is evenly spread out and the temperature of cosmic background radiation is consistent hints at something endless. This opens up wild questions. If the universe is infinite, what does that mean for us? Are there infinite versions of everything, including you and me? And if the universe is infinitely old, how do we explain what came before the Big Bang? These aren't just questions for science fiction. They're the real puzzles scientists are grappling with now. Every new image from the Webb telescope feels like a plot twist in a story we thought we had figured out. Galaxies forming too quickly, black holes merging too soon, and the possible realization that the universe has no clear boundaries in space or time. It's like the universe is trolling us, daring us to figure it out. As more data rolls in, one thing is clear. The universe is way more complicated, mysterious, and mind-boggling than we ever imagined. And the Webb telescope is just getting started. Let's dive deeper into the intricate discoveries that push the boundaries of what we thought was possible. Imagine this. Every time the telescope captures a deep field image, it's like opening a treasure chest full of secrets that reshape our understanding. For example, astronomers once thought galaxies in the early universe would be small and chaotic. Instead, the Webb telescope found galaxies that were surprisingly mature and well-organized just a few hundred million years after the Big Bang. These findings challenge the very foundation of the standard cosmological model. Even more puzzling is the fact that the telescope detected light from the earliest stars, called population 3 stars, which were made almost entirely of hydrogen and helium. These stars are thought to have kick-started the formation of heavier elements. Yet their existence within such a short time frame of the Big Bang raises big questions. How did they form so quickly? What mechanisms allowed for their rapid development? These stars might hold the key to understanding the origins of everything we see around us today. Another astonishing discovery involves the mysterious dark matter and dark energy that make up most of the universe. While we can't see or directly measure these components, their effects are visible in the way galaxies move, and the way light bends around massive objects. The Webb telescope's precision is shedding new light on these phenomena, potentially offering clues about what this invisible part of the universe is made of. Behind the discoveries lies the story of how we made them possible. A billion-dollar gamble. The James Webb Space Telescope is a jaw-dropping piece of tech that's rewriting what humans can do in space. Forget about just looking at stars. This thing is built to peer into the universe's deep past, poking around in the first moments after the Big Bang. Fancy stuff, right? But the story of how it came to be isn't all smooth sailing. It's packed with big dreams, frustrating delays, and more than a few moments of people scratching their heads wondering, will this ever even work? Back in the 1990s, scientists were buzzing over the Hubble Space Telescope's success. They wanted more, a telescope that could see things Hubble couldn't. The big idea? Build something that could pick up infrared light, which is perfect for cutting through cosmic dust clouds and spying on the first stars and galaxies. Around 1996, a team of experts decided they needed a telescope with a massive mirror over 4 meters wide, and it had to hang out in space way beyond Earth's moon. That's how the idea for the next generation space telescope, the James Webb Space Telescope's original name, got rolling. Building it, though, not easy. The telescope was renamed in 2002 to honor James Webb, a NASA bigwig, and what followed was years of design tweaks and tech experiments. Its main mirror, 6.5 meters across, is made up of 18 gold-coated hexagons. The gold? Not just for looks, it's perfect for reflecting infrared light. And then there's the sun shield, which is basically a tennis court-sized 5-layer blanket, keeping the telescope super cold. Why so chilly? Heat messes with infrared observations. Making that sun shield fold and unfold just right? A nightmare. Engineers tested it again and again, because if it failed in space, there's no repair crew to call. Progress wasn't fast. By 2011, they were finally putting pieces together. First, the mirror segments got assembled. Then came the secondary mirror. Each piece had to survive extreme tests: freezing cold, violent shaking, and deafening noise. All that to make sure it could handle being blasted into space and still work like a charm. But the road to launch was full of potholes. This telescope was supposed to be in space by 2007 with a budget of $500 million. Instead, the price tag ballooned to $10 billion, and the launch date got pushed back again and again. One of the worst setbacks happened in 2018 when the sun shield ripped during a test. Fixing that alone ate up months. It wasn't just the United States Space Agency working on this monster project. Europe's space agency pitched in with a rocket to launch it, and Canada added some crucial instruments for navigation and imaging. This wasn't just a solo mission, it was a global team effort, with different countries splitting the cost and brainpower. Finally, on Christmas Day in 2021, the James Webb Space Telescope took off on a rocket from French Guiana. The launch went better than anyone could have hoped. The rocket aimed so well that it saved a ton of fuel, which might let the telescope last even longer than its 10-year goal. Then came the tricky part: getting everything set up. The telescope had to unfold its mirrors and sun shield while traveling 1.5 million kilometers away from Earth. Each step had to be perfect. Hundreds of things could have gone wrong, but somehow everything clicked into place. After it reached its destination at the second Lagrange point, the team spent 6 months making sure everything worked. They aligned the mirrors, calibrated the instruments, and double-checked all the systems. By July 2022, the first full-color images were released, and they were worth the wait. The detail, the clarity, the sheer depth of what the James Webb Space Telescope could see, it blew everyone away. This telescope isn't just about pretty pictures. It's digging into the biggest questions humans have ever asked. How did the first galaxies form? Where do stars and planets come from? Is there life out there somewhere? Thanks to its infrared vision, the James Webb Space Telescope can see through dust clouds that hide these answers and even catch the faint light from the universe's early days. It's safe to say the James Webb Space Telescope is a game changer. After decades of work, countless delays, and a price tag that made everyone wince, it's finally delivering on its promise to unlock the secrets of the cosmos. And for all the headaches it caused, it's already proving to be worth every penny. Should humanity prioritize space exploration over Earth's problems? Share your thoughts below. Like, comment, and subscribe for more insights into the universe and humanity's biggest questions.